This is IB mock test on chapters 5 and 6, the first question. And the first question says an elevator motor speeds up a 543 kilogram elevator from, so it's 543 kilograms. And it speeds it up from 5 meters per second to 9 meters per second. So here it is, it's going 5 meters per second. And later it's going 9 meters per second. And this distance here is 7.5 meters. And there is a friction force of 850 newtons is the friction force. Right? And so the first question is, what is the elevator's change in kinetic and potential energy? And just be careful when you do kinetic energy is 1/2 mv squared. You have to do this twice. You have to say that it's 1/2 mv squared minus 1/2 mv squared, right? So it's going to be 1/2 543 times 9 squared, right, minus 1/2 543 times 5 squared, right? So the change in kinetic energy, don't try to subtract the 9 and the 5 and do it that way because it just doesn't work. Try it. I mean, try it both ways, but it's not going to work. Okay, so 0.5 times 543 times 9 squared minus 0.5 times 543 times 5 squared. I'm just doing that all in one swell foop here. And I get that it's 15,204 joules. That's gained of kinetic energy. So that's one of the answers. Right? And then the other answer is what's the change in potential energy? Well, this one has, it's like this, right? mg delta h, right? So this is easy, right? It's going to be 543 times 9.81. 9.81. Just doing a sound check here, right? Times, and then it's 7.5 meters. Is that right? 7.5 meters. Yeah, it is. Okay. And so that equals, I'm going to store this, by the way, in the kinetic in A, and then I'm going to go 543 times 9.81 times 7.5. I'm going to store that in B. And this is 39,951.225 joules, and this is plus of potential energy, right? Okay. And so there's those answers, right? B says, what force must the motor exert on the elevator? So this is A, right? To find the force, I think what we're going to do is we're going to say force times distance, because it's definitely a speeding us up force, right? Plus 1/2 mv squared. It's moving, right? So there's going to be a speeding us up force. It is already moving, right? And that's going to turn into work against friction. And it's going to turn into mgh, and it's going to turn into 1/2 mv squared. Yeah? Wow, this is, do you feel this? This is a special moment. This is a 2 turning into a 3. You know, right? So it's some unknown force times 7.5 meters, right? Plus 1/2 543 times 5 squared, right? Plus, and then the force that's opposing us is our 850, right? Whoops, not plus, that equals 850 plus 1/2 543 9 squared. So I'm going to do this. So what I'm going to do is I'm going to go, oh, did I forget? No. I'm forgetting mgh, aren't I? Plus 543 times 9.81 times 7.5, right? Notice that the only distance in town is 7.5. Both the friction force, the elevator's motor, and the potential energy have the same, act over the same distance. And that's real common in these kinds of problems. Right? Okay, so 543 times 9.81 times 7.5 plus 0.5 times 543 times 9 squared times, oops, not times, I want a plus 850 times 7.5. Now I'm going to subtract this guy, so minus 0.5 times 543 times 5 squared. And I get that force times 7.5 equals 61,530. Right, and now I can divide by 7.5. Hopefully this will give me the right answer. Yeah, I get that force equals 8,204.03 newtons. And then it says, what force must the motor exert to make the elevator move at a constant speed? Well, presumably it's going to move at this speed, right? So it's going to be force times 7.5, right? Plus 1/2 543 times 5 squared, right? Equals, there still is going to be friction, right? Yeah? 850 times 7.5, right? The kinetic energy will be different. If it's a constant speed, it'll be going 5 meters per second, right? So 1/2 543 5 squared, and then it still has to go up, right? So it's still going to be 543 9.81. Right. Now, notice this is something special here, right? That goes the way of the bison, right? It's on the same on both sides, right? So basically it's going to be this guy here, 850 times 7.5, right? Plus 543 times 9.81 times 7.5, right? And that's 46,326.225 joules is force times 7.5. So if I divide that by 7.5, I get ta-da. And that's the answer there, right? Now, the question you've got is, there's got to be some way to use these values here. Well, of course it is, right? You can just say that, for this guy anyway, right, that the force times distance, right, is going to equal the change in kinetic energy, right? Plus the change in potential. This is change in kinetic energy, right? Plus the change in potential. Plus the work, right? All right, so all I have to do is just divide all of this stuff, right? So my alpha A plus alpha B, right, plus 850 times 7.5 divided by 7.5. And I get the same answer. I get the 8204, right? And then for this guy here, right, all I have to do is say Fs equals, we still have to gain potential, we still have to do work, but we don't have to do that, right? So no gaining kinetic, but we still have to gain potential, 39,951.225. Right? So I just go alpha B plus 850 times 7.5, right? So these two numbers, right?